Okay, so this workshop is about the third component of the three-equation model, namely monetary rule. So informally, we can say that monetary rule represents the policy response of the central bank. And to describe it formally, we have to start with the function of losses of the central bank. So, as you remember, there are two key responsibilities of the central bank, which are maintaining financial stability and promoting full employment. So, respectively, the losses of the central bank would depend, on how much economy actually deviates in terms of inflation and in terms of output from, some target levels of inflation and output. So that's how we describe this. So first we start with inflation. Pi t stands for the level of inflation, and pi tau stands for the target level of inflation. So we assume that central bank is actually indifferent between the situation when inflation is above the target level or below the target level. So in this case, direction does not matter. Central bank is solely interested in magnitude. So, just to reflect this fact, we put everything to square, because in this case, again, inflation, like 2% deviation from the target level would give the same indicator in terms of losses, regardless of whether this deviation is actually positive or negative. So then we introduce deviation in terms of employment or output, because as we discussed, they are directly linked to each other. So YT stands for the level of output, and YE stands for the potential output. So output in full employment or output when economy is in the long run equilibrium. So analogously, it does not really matter whether the economy is in inflationary gap when level of output exceeds potential output, or whether economy is in deflationary gap when level of output is below potential output. We are just interested in, the magnitude, like the absolute value of deviation. That's why, again, we put everything to square. So finally, we introduce variable beta. And again, informally, you can say that beta reflects the relative importance of those two objectives for the central bank. So to explain this, let us introduce three examples. So first, assume that beta is equal to 1. So okay, so we depict this perfect situation of the central bank when inflation is equal to pi tau and output is equal to potential output. So this is the point at which losses of the central bank are equal to 0. Because there is no deviation in terms of inflation and no deviation in terms of output or employment. So the fact that beta is equal to 1 means that central bank is neutral. Neutral between those two objectives. So if there is a deviation in terms of output, so here we move to the point with the same level of inflation, but deflationary gap when output is below equilibrium output level, it's as bad as equivalent deviation in terms of inflation. So those objectives are equally important, and here I do not know, technically it's not an indifference curve, maybe like iso loss. So on this circle, the losses of the central bank are identical, because as I said, we are not interested in the direction of deviation. So this point is as good as this point, with decrease in output or increase in output. And we do not distinguish between deviations in terms of inflation and output, because in this case, they are treated as equally important objectives. So that's why, those isolos curves will be represented by the perfectly symmetrical circles. Okay, so as I mentioned before, A is a perfect point for the central bank because in this case, there is no output gap, there is no difference between inflation and target level of inflation, so losses are equal to 0. And when we deviate from this perfect point, when we move from inner circle to the outer circle, because again, on this circle here, each of the combinations of output and inflation is equivalently good or equivalently bad for the central bank. Like here we discuss losses, so let's say equivalently bad. So, and when you move from inner to outer circle, the losses of the central bank will increase. So, speaking informally, if central bank has to choose between being located on this circle or on this circle, central bank will always choose the circle which is closer to this point. Okay, I believe it's clear, so let's proceed to the next example. Assume that beta is greater than 1. So in this case, we say that central bank is inflation averse, or characterized by inflation aversion, if you wish. So in order to explain the logic, and analyze the shape of the isolos curves, technically speaking, this is indifference curve as well. Okay, whatever. So actually, here you also start with this perfect point, point A, at which losses of the central bank are equal to 0 because there is no output gap and no deviation in terms of inflation from the target level of inflation. So, central bank would definitely like to be located at A. The fact that beta is bigger than 1 and central bank is inflation averse implies that relatively small deviation in inflation is equally bad as relatively big deviation in terms of output. So let's say here, when we move from point A to this point, we have no deviation in terms of output and relatively small deviation in terms of inflation. And this point is as bad as the situation when we have large deviation in terms of output and again, no deviation in terms of inflation. So because as I said, the objective of financial stability is assigned a higher priority for the central bank. That's why those circles will look in this way. Again, the same rule applies. When you move from inner to outer circle, losses of the central bank increase. And when choosing between, let's say, this circle and this circle, like isolos curve and this isolos curve, central bank would be located at this curve because this one is associated with smaller value of losses. So finally, we have a situation when beta is less than 1. And in this case, we say that central bank is unemployment averse. So in this case, relatively small deviation in terms of output is equally bad for the central bank as a relatively big deviation in terms of inflation. So again, yp, we start with some, ideal point when pi is equal to pi tau and output is equal to potential output. So this point A, at which losses of the central bank are equal to 0. And if we have to deviate from this point, then again, if we move from this point to this point, then we have the same level of inflation. We have the same level of inflation, but relatively small deviation in terms of output. So this is equivalently good or equivalently bad as having the same level of output, but big deviation in terms of inflation. So in this case, those circles will look in this way. And again, when we move from inner to outer circle, losses of the central bank will increase. Okay, so I believe it's clear. So as the rational agent, central bank would always like to minimize the losses, and try to be located as close as possible to this target. And as usual, when we analyze any kind of optimization, we require a constraint. In our case, for the central bank, the constraint of optimization, like for cost minimization, the constraint for cost minimization is represented by the Phillips curve. So let me draw the graph. Sorry, 1 second. Okay. So here we are. For the sake of simplicity, let's assume that beta is equal to 1. Okay, so here we have some optimal point when output is equal to potential output and inflation is equal to pi tau, or the target level of inflation. And here obviously we have the point of central bank losses minimization. So let's draw a couple of iso-loss curves. Iso-loss, okay, whatever. Again, I assume that beta is equal to 1. That's why those curves will be represented by the perfectly symmetrical circles. Okay, that's enough. It's visible. Okay, not that visible. Okay, so let's say here we have L equal to 0, L0, L1, and L3. Okay, fine. That will do. So, as you remember, the formula of the Phillips curve is rate of inflation equal to expected rate of inflation in the same period plus alpha times output gap, yt minus ye. And when it comes to, expectations about the level of inflation, we assume adaptive inflationary expectations. So basically we assume that pi e t is equal to pi to pi t minus 1. So expected rate of inflation in period t is equal to the rate of inflation in the previous period. So if I need to predict the rate of inflation for 2021, and if I have adaptive inflationary expectations, I automatically assume that the rate of inflation in 2021 will be the same as in 2020. So yeah, by definition, this is just, due to the fact of adaptive inflationary expectations. Okay, so here we have Phillips curve. And let's say that here, we can draw several Phillips curve depending on the level of inflation in the previous period. Okay, so if we are here, like here we have PC1. So at this point, when Phillips curve has a common point with central bank indifference curve, because again, at this point, the entire indifference curve is just one point, of optimal combination of output and inflation. So in this case, the requirement is that expected rate of inflation is equal to pi tau. So you can easily prove this just looking at the functional form of the Phillips curve. So at this point, output gap is equal to 0. So inflation has to be equal to expected rate of inflation. So here is our empirical level of inflation, what we can observe empirically. And automatically, if this one is equal to pi tau, the expected rate of inflation is also to be equal to pi tau because we assume 0 output gap. So this automatically implies that in the period -1, the rate of inflation also was equal to pi tau. So expected rate of inflation in the current period is equal to pi tau. So this automatically implies, under adaptive inflationary expectations, that in the previous period, inflation was also equal to pi tau. Okay, I believe it's clear. Here we have PC2, and here, okay, so just the intercept of and here actually the expected rate of inflation is equal to pi 1 because again at this point we have no output gap. So in order to be located at this point, it should be higher. Like obviously pi 1 exceeds pi tau. And take a look. Here Phillips curve serves as a constraint because central bank has nothing to do with Phillips curve. So Phillips curve, the shape of Phillips curve, to be more precise, the intercept of Phillips curve, is determined by the rate of inflation in the previous period. So yeah, and basically since it's already out of control of the central bank treats Phillips curve as a constraint. So although central bank would like to be located at this point, this would require having rate of inflation in the previous period equal to pi tau. That's why for the central bank, you just deal with what you've got in this case. So if things are not that bright for the central bank, and in the previous period the rate of inflation exceeded pi tau, we deal with this Phillips curve, PC2. Okay, and here actually central bank has 3 possible options to choose between. Like central bank can choose this combination of output and inflation, this combination of output and inflation, or let's say, maybe this combination of output and inflation. I believe it's more illustrative because in this case, pi tau, inflation is equal to pi tau. At this point, output is equal to potential output. So let's say here we have point, okay, this was point A, so maybe point B, C, and D. And let's also introduce point E. Okay, so as I said before, Phillips curve is a constraint. So you know it's determined by the past events, past rate of inflation, and some exogenous variables, for instance, parameters probably, for instance, alpha, which are out of control for the central bank. So basically, central bank treats Phillips curve as some external constraint, and central bank can choose between combinations of output and inflation, which are located only on Phillips curve. So in this case, point D might be, hypothetically, it will not be, but let us just imagine. It might be a desirable point, but it's simply not achievable because it's not located under Phillips curve. Analogously as point A, it's a desired point. So basically we can prove that this is the most desirable combination of output and inflation for the central bank, but it's simply unachievable. So let's take a look. So in fact, here central bank can choose between B, C, and E. So B and E are located on L3. Okay, actually it was to be L2. Yeah, L0, L1, and 2. Then it's more consistent. Okay, so for the central bank, B and E are located on L2 and C is located on L1. So out of those three available points, central bank has to choose such a point which would minimize losses. And as I mentioned before, losses decrease when you move from outer circle to inner circle. So if the central bank has to choose between being located on L2 and being located on L1, central bank will definitely prefer L1. So here, central bank will prefer point C. Because again, point C is the only point which is located on L1. Like the rest of available options will be located on outer, in comparison to L1 to outer indifference curves or iso-loss curves if you prefer. So C in this case is the optimal option. Analogously, we can imagine that things are even worse, so there was even higher rate of inflation in the past period. So we draw another Phillips curve. So let's say this is PC3. And just following the same rule, this point of tangency, will be optimal point for the central bank. So actually, monetary rule will consist of all the points at which Phillips curve, like each possible Phillips curve, is tangent to the iso-loss curves or indifference curves. So what we have to do is to match all of those points, and here you get monetary rule. So once again, monetary rule consists of all the loss minimizing combinations of inflation and output, depending on any shape of the Phillips curve. And when I say any shape of Phillips curve, it implies inflation in the past period. So here we assume that alpha is constant, so this is some parameter which is not subject to change, and only inflation in the previous period will be affected. Okay, so I believe this part was fine. Let's proceed to the final one. So when it comes to the formula of monetary rule, so as I said here, central bank can minimize losses when being located at the point of tangency of either iso-loss curve and Phillips curve. So basically it implies that the slope of iso-loss curve is equal to the slope of Phillips curve. So this is the definition of tangency, if two functions are tangent, it means that there is a point when they have the same slope. So in this case, the condition for deriving MR rule will require us to equalize slope of Phillips curve to the slope of iso-loss or indifference curve, whatever. Actually, I like iso-loss more because it's more illustrative. Okay, so for Phillips curve, the formula is pi t is equal to expected rate of inflation in period t, which is equivalent, to rate of inflation in the previous period, plus alpha times output gap, yt minus ye. So here actually, when you open the brackets, you will get pi t equal to pi e tau, pi et minus alpha ye plus alpha yt. So this will stand for the value of intercept and this part would depend on the level of output. So the slope of Phillips curve is equal to alpha. So from Phillips curve, d pi t over d yt is simply equal to alpha. Okay, when it comes to iso-loss curve, it will require more complicated analysis, and in this case we can elaborate on the implicit function theorem. So as you can recall from the course of math, implicit function theorem implies that here we have the function L of two independent variables, which are pi t and yt. So if you want to define the derivative of pi t with respect to yt, which basically will stand for the slope, because here we have pi on vertical axis, then you have to divide derivative of L, partial derivative of L with respect to yt by the partial derivative of L with respect to pi t, and you put minus in front of this expression. Okay, so is it still visible? Yeah, it's still visible. Good. Okay, so as you remember, L was represented by beta pi t minus pi tau square plus yt minus ye square. For the sake of simplicity, let's open the brackets. It will simplify our life a bit. You will get beta to pi t square minus 2 pi t pi tau plus 2 pi tau. Sorry, I already differentiated. Plus pi tau square plus yt square minus 2 yt ye plus ye square. Fine. Okay, it's not visible already at this point. Okay, let me just rewrite this. Okay, again, monetary rule was represented by beta pi t minus pi tau square plus yt minus ye square. So when you open the brackets, you will get L is equal to beta pi t square minus 2 pi t pi tau plus 2 pi tau, I do the same stuff, plus pi tau square plus yt square minus 2yt ye plus ye square. Okay, is it visible? Yes, it's still visible. Fine. Okay, so in order to calculate partial derivative of L with respect to yt actually, so then you get 2yt minus 2ye, which is equal to 2yt minus ye. Fine. So derivative of L with respect to inflation pi t will be equal to 2 beta pi t minus pi tau. Fine. So now derivative of pi tau with respect to pi t with respect to yt will be, so you have to divide this part by this part. And we shall get 2 yt minus ye by 2 beta pi t minus pi tau, which gives you minus yt minus ye divided by beta pi t minus pi tau. Okay, looks fine. So now finally, so this will be the slope of isolos. So now we have to equalize it to the slope of Phillips curve, which is basically alpha. So now alpha is equal to, okay, maybe minus alpha is equal to yt minus ye divided by beta pi t minus pi tau. Okay, so from this, you get yt minus ye equal to minus alpha beta pi t minus pi tau. You know, this is the way in which it's presented in your textbook. And, you know, just to simplify the analysis, and since we assume that everything is linear, I believe it makes sense to express this function as the function, like to rearrange this to get the function of pi t. So we get pi t minus pi tau is equal to minus 1 over alpha times beta times output gap yt minus ye. Then pi t will be equal to minus 1 over alpha beta times yt minus ye plus pi tau. And here we are finally done. So this expression stands for the formula of monetary rule curve. Okay. Shall we rearrange it at this point? No, we will do this later on when we proceed to supplied side shock. So here, the functional form of this equation will depend on the value of alpha and value of beta, where alpha stands for sensitivity of wages to the size of output gap and beta stands for the degree of inflation aversion of the central bank. Ye would stand for potential output. Pi tau stand for target level of inflation. So here basically when we will analyze it formally using three-equation model, we're gonna assume all of those as exogenous parameters and yt as the only endogenous parameter. So we will analyze the relationship between pi t and yt and how it would depend on the values of those variables and parameters. Okay, I believe it's enough for this video. So thank you for your attention.